Yeah, hi there. Happy to be here. My name is Maximilian. I'm You're speaking human now for the next 30 minutes, and I'm speaking about speaking machines. I'm the author of the ChatGPT list of lists, at the moment one of the most comprehensive sources on that topic. I'm a researcher, a practitioner, and a speaker in the field of AI since about 5 years or so. And things are evolving very fast in the AI in the moment. I was here at a talk last summer, and I was asking my audience, who ever heard of large language models? And it was about 10 to 20%. Let's make ask this question again. Who has ever heard of ChatGPT or large language models? Okay, it's really something like 100, from 10 to 100 in the last couple of months. The reason is basically here. The release of ChatGPT marked something like an iPhone moment of AI, a pivotal moment in the history of artificial intelligence. In just 5 days, ChatGPT amassed 1 million users. That's a feat that took other platforms like Instagram or Facebook months or even years to achieve. And it didn't stop here. ChatGPT went on to get the fastest growing consumer application ever, really ever, which changed coming to an estimated 100 million users in a record time of only 2 months, which changed about everything in the field of AI. Now everybody is asking not if, but how should they integrate that into their applications, platforms, services, processes. Let's have a look into the conversation with AI. I have to admit one thing. I did cheat. The spoken text from the last slide, I was only the parrot. Yeah, I spoke a text really ChatGPT generated for me. Here you see the dialogue. You can't completely see it. I give it some input in form of bullets. It writes me a text. I give some feedback on that. Now, please change that. Please change this. And then it gives me the final text, and you can really use it in business applications. And you're working with it like with a coworker. It's not like programming anything, but it's really your writing buddy, your coding buddy, your learning buddy. If you can't read the text, there will be many more conversations in the next slide. Come a little bit closer if it's not possible for you to read it. So question, how does this work? Let's dive a little bit deeper into the workings of the machines. One ingredient to the incredible success of these models is really the growth. They're growing 5-fold to 10-fold every year in the last years, meaning really getting 5 times or 10 times bigger every year. If my brain had grown in this pace in the last years, it now would be the size of a small truck. Sounds a little bit uncomfortable. I'm happy that it's not like this, but that's the growth. If you look at the data they devoured really half of the internet. They got a complete Wikipedia in many languages, but much more. For instance, ChatGPT read in content in a size where I, as a human, would need some 100 lives of only reading, doing nothing else than reading to take the content in. 100 lives of reading the internet, that's really sounding a little bit like the maximum sentence again. But how do they generate their answers? They're not hard-coded in any way. They're doing it based on stochastics, based on the statistics of the learnings they had in their pre-training. They're generating their answer token by token. The pink one is the token with the highest probability, but there are other ways to answer the questions as well. So if you read that, who did invent the automobile? The answer is, the most probable answer is, the first automobile was invented by Carl Benz. There could have been other answers, like Carl Benz invented the automobile, Carl Benz was the inventor of the automobile. Something like that would have been possible as well. What you see here, if you think a little bit, it's completely semantically stable. It's always the same meaning, but it's syntactically flexible. It could be different sentences. It's like talking to a human, where you often don't know exactly what sentence will come out, but what he will talk about when you ask him something. We have prediction engines here as well, generating token by token. If I give you the start of a sentence, your brain would automatically trying to go forward and trying to predict how might it go on. You even can't stop it from doing that. It's not only about language and text. Here you have a sentence like, a cute raccoon has broken its chain and is now leaving the dark dungeon. Dramatic light, photorealistic, exquisite details. I sent that sentence to a generative AI art model, and that is the outcome. It's only that. It's not much more. I don't have additional data about the colors or about how it should look like. It's generating it only based on that and on its pre-training it had in the internet. It looks like that an artist or designer might have designed that. In reality, you see, it's not really good visible, but if you come a little bit closer, often the fingers, the count doesn't sum up. It's only 4 or 6 or 7 or something. This is typically something like a watermark of the models, but else it looks like really generated by an artist. There are many fields of generative AI models, like text, like image, like code. These are super important, but there are other fields like video, like chemistry, like medicine, and so on, where they can generate, based on a large number of inputs, the outputs as well. The mechanism is almost always the same. It's trillions of data points. They learn, and then they are able to generate the answer based on that learning. In every field we see here. If we look at the company landscape of generative AI, you see down there on the left, the big 5 are in here. It's Microsoft, it's Google, it's Amazon, it's Apple, and it's Facebook who are in there, but most of the work is done by smaller startups. There are hundreds of them working in different fields of generative AI, and the landscape is changing very fast. Here, for instance, for OpenAI, you see a valuation of 20 billion. It's now 6 weeks later. In reality, it's close to 30 billion now, because Microsoft has invested 6 weeks ago 10 billion into the company. The complete investments in the AI sector is about 40 to 60 billion a year at the moment, and the forecast says it will go up to the double or triple in the upcoming 3 to 5 years. So there's a lot of money in there. I would love to discuss what does this mean for Europe, for European techs and startups. What is the role of China? What is Google actually doing at the moment? Things like that. Maybe we can come back to that in our table discussion. But now let's move on to a real-world application. How can we use that actually? What is the opportunity? The opportunity with large language models is really to process any language-based information and communication with natural language prompts. No programming. If you look at classic language processing processes. You have complicated scripts, filtering emails, classifying them, and then trying to answer them based on templates. You have to have all edge cases covered, and there is a super high rate of misprocessing. Usually, it's hard to do it on a business scale. If you go to generative models, it's completely different. You give it an instruction in natural language, like classify the mail in 1 to 5 in these 5 categories. You list the categories. You need 2 examples for each category, and you work with it like with a human coworker, basically like with a trainee. If it isn't enough, you give more examples. And that works. And that is really the opportunity, and that is really the thing that makes a difference to classical software engineering. Here you can apply natural language instructions to all of your language-based communication and information you have. For other fields, it's a little bit more tricky, but for language-based things, you can really use that kind of processing. So what could that be for or mean for applications in detail? There are some low-hanging fruits. Basically, most inquiries, most clients who ask us, it's not about big new applications. It's asking, how could we optimize our call centers? How could we optimize existing chatbots? And here you can build in a large language model component into these existing solutions with not much invest. This is not really heavy. It's really a low-hanging fruit here at this moment, and can enhance the quality based on the user experience, or in the call center, for instance, based on the case completion rate. The sweet spot is a little bit more up. You can build new applications like automated email answerings, go into a product or service text chat in a website, build new chatbots in other fields. For instance, if you integrate a chatbot into your website, this could mean your clients can be really consulted by a virtual personality knowing everything about your product. And that's really interesting. That's one thing which could be really interesting. The invest is maybe a little bit higher than at the low-hanging fruits, but the outcome in terms of user experience and automation is much higher. What we would not advise is to try to completely automate or replace one human role. Like take one person and do everything that it can be automated. Usually it's way easier to automate something like 10% of 20 roles than 100% of one role. And for most graduate jobs, regardless of the invest, usually it would not work. You would not be able to fully replace it. For the strategic targets, there is a product integration of chatbots into your, for instance, physical products, into your car, into your phone, into your home, and things like that. Make them speak, make them communicate with the user. Or here at the left-hand side, make a textbook, learn with the pupil, with the student. There are other possibilities as well, like a full business process automation, or even making machines or single applications talk to each other in natural language without a defined interface. Things like these, they're really a little bit more far-fetching. But take 10 or 15 seconds in your mind for your business area. You will be able to identify other things, other ways to get to a new user experience, to get to a new way of automation, if you think a little bit in regards of your challenges. Let's now dive deep into one application. Here we have an email which is answered automatically. How does this work? In this email, That's a request for quotation. Somebody asks, here is the to, here is the from, here is the when, here's the what. What would this transport cost? And sends this email to, to a logistics company. The large language model is able to get the payload out of this email and format it in a way that you can throw it into a transport management system, which then writes down one offer or two offer, which you again can send per email to the client. This thing has something like a case completion rate of 85%, meaning that you still have to send 15% of the emails to a human operator because they are too complex or asking two things or asking too many things. So you can't answer it by the analysis of the large language model. But 85% email answering and correct email answering is great. But it's not the greatest thing. What is the greatest thing in this solution? I want to bring your token engine a little bit in direction of overdrive. The greatest thing here is really customer experience. Imagine you write an email, click on send, take a sip of coffee, and before you put down the mug, the answer is here in your inbox. It's not a confirmation reception, it's the answer of your email. You get an offer and you can directly book it. For many of the clients, this was not cool, this was close to magic. It's sometimes then hard to understand, does this really work? Trying again with other data, does this really work? But it works. And this is really an interesting thing, how you can completely change the customer experience with a process by just making it automized and much faster. Another example is analyzing CVs from candidates, sending them to large language model, which gets the payload of the data out in here and writes it into an HR system. In case one field is missing, it can generate an email to the candidate and ask, hey, how's it with your fluency in German, for instance? And if he answers, then you could put it back into the system. This one is a little bit trickier. This is not really easy and straightforward, but it's a really cool process. It's the integration of a large language model into a physical product. Here in this case, it's a car. Let's have a look at the dialogue. Take your time reading it. It's emotional chit-chat, the first things. It's commands. It's questions about car data and car features. This is not part of a serious car now at the moment. This is still a prototype. Many car makers are researching into these processes and are working on that kind of experience. If you think at your car and your in-car experience and how you could talk to your car, it would be super interesting to see something like that. And we could hope for that we see something like that in about a year or 2 years in our cars. But it's not really trivial to build it. Here again, it's not just a human-computer interface we are changing, but we change the complete perception of the car when we do things like that. It's not anymore something like an hearing-impaired receiver of your commands, but it's a companion. It's a real companion. It can chat with you. It can help you on your journey. It's something like Kit in Knight Rider, a thing you can really live and work with. I'm going very fast on that. Usually it's not enough to have a large language model here, but you need other components like classic NLP systems, retriever-based systems here as well. Next little example is a chatbot based on a large language model where you just throw in your company data, like users' manuals, instruction manuals, and let it answer questions of the user. The user has a big problem with the quality of the coffee. So the bot asks, okay, what is the problem? It's the crema. Yeah, it's not creamy at all. So let's look up. They are looking in the owner's manual and generating an answer based on the documents. And they're able to answer questions like that, which are not fully qualified. What is that? To what refers it? But the model is intelligent enough to see that referral and answer the question in the end. Here again, this is a solution you can build in any language, not just in English. You can do it in any major European language. You can do it as voice. You can do it as text if you want to. And in the end, you can roll it out, such a solution worldwide for all products based on your documents. Going, because the time is a little bit short, going fast over that. One thing which is really thrilling is to tell a large language model, you are XYZ. In this case, you are Aragorn from Lord of the Rings. This could be a setup in a metaverse. It could be an application. It could be an app. And then it can answer user questions based on the knowledge it has. It can transform any knowledge, like Aragorn is in love with Arwen, into first person. I am in love with Arwen, and interpret that in this way. And one thing which is really cute, which the models can do as well, they can spin a story far behind their material. For instance, if the user wants to dive deeper into this world of Middle-earth and all these adventures, they can generate stories based on the settings and the character here as well. So now comes the disclaimer. There are a lot of challenges when you try to build generative AI solutions, and I will talk about some of them. You may have heard that all these models are biased. So biased against minorities, against women, against specific ethnic groups, and so on. And this is real. They have the same bias as the internet data they were trained on. That's quite logical. They can't be better than the internet data they were really trained on. But for us, for building business applications, it's usually just an academic problem, because we use our data. And we have the data usually, if you're talking about Western European businesses as I know it, I don't know it from everywhere, these data are cleaned from all these bias things, otherwise you have a problem anyway. And so this is not a big problem. At the moment, we didn't experience that. That's a huge one. If you know classic NLP solutions, something like the chatbots you use or Alexa or the things in your car, often they have trouble understanding you. This is not a problem with generative AI models. They can always generate an answer, which doesn't mean that this answer is necessarily correct. And this is a really huge problem. It can't be completely wrong, or wrong in parts, or incomplete. And often for some applications, you have to completely get that out. So we are doing services for the automotive industry, what you've seen, or for the chemical industry. You have to be factually right in every answer. And this is a hard one, and you have to really work on that. The next one is evaluation. It's not that easy because they're generating their answers freely. You can't compare them to a set of correct answers because they will be always different. So the thing is, you have to transfer their answer in a vector in a 1000-dimension space and compare it with the target answer. It's a lot of math involved that you can do that, but you can do that. But it's work. It's really work. The last one is getting your company data ready, which is a huge task. Not for a one-off. If I do the thing with the coffee machine, it takes me maybe hours to prepare the manual in a way that I can use it for a chatbot. But you don't have one coffee machine, you don't have one generation of coffee machine, you don't have one language, but usually if you're a little bit bigger business, you have your service condition in one market changed next week, and then new product releases in every market once a year, and change product with change descriptions every 6 months or something like that. And then you're going into new markets and have to translate the material. So in the end, you don't want to manually change the content each time anew. You need a content pipeline. And this is a lot of work. Working on something like hundreds or thousands of documents in your enterprise. If you count it up, all the efforts in a project on these things, it's something like 50 to 60% efforts which you don't have in a normal software development project. But still something like 40 to 50% is things everybody here in the room may be familiar with. It's about requirements engineering, UX, UI, front-end, back-end development, testing, hosting, and things like that. But these things are really new, and sometimes they're really hard to solve. Don't fear, I'm not going into every detail here because we are quite short in time. The only thing I want you to do is making something like a mental note. The large language models are only one player in a large orchestra to build a complete solution. Usually you can't use them standalone. They are most important player to be in the picture. It's something like a mix of a conductor and the grand piano player. They're visible and they're really loud, but it's not the only thing. You need much more to build a real solution based on that. The good thing is most of the other components you have here come really ready-made. There are existing libraries or software solutions or services you can connect. So you can, if you choose the right things, you can quite easily build the complete solution around it. But it's not just a large language model that you can use ChatGPT out of the box for a meaningful business application. Maybe last but one slide, one note. Many of our clients and partners, mostly European customers, have a problem of sending their company data or their user utterances to California, to a US-based model, and then look what happens. Very often, this is one of the loudest concern we always hear. We can't do that. No, our corporate compliance and GDPR doesn't allow that. There's one good news on that. You now have an open source model which you can run in your own cloud. This is the Bloom model. We did that. It's really huge. It's as big as GPT-3. We did that, and it's really hard to do it. It needs something like, if anybody of you knows that, 8 NVIDIA A100s to just run it, each with 40 each GPU with 40 gigabyte of RAM. This is really huge, and it's not really cheap to run. It's getting cheaper, but at the moment it's it's quite costly to run it, but you can do it, and if you have a larger application, it's absolutely worth to do it. A late introduction from our side. We are Big Picture. We are a Berlin-based boutique working on digital transformation with about 150 employees in the group. We are usually interested in a project when it's customer experience heavy, when it's technology heavy, and when it's information heavy, innovation heavy, then our ears perk up, and we do solution beyond the large language models. Often our solutions are just GUI-based solutions where we can work out with our clients other ways without large language models, with other forms of UI. But one of our focus areas is now UI. We're working with a lot of the bigger companies in Europe, but as well as with some startups. So, my dear fellow humans, I'm coming to the end of my talk. Thank you very much for the attention here. I would really love to switch now from a machine-based conversation to something like an intra-species talk, where we can grab a cup of coffee and sit down, and things you can't do with your machines. And I think the roundtable talks, they will start in about some minutes. And if you can't participate, please feel free to contact me on questions or ideas.